Hey guys, this is Alan. Today I'm going to talk about why cheaper models will not save your AI budget. Recently, I read a paper called The Harness Effect. The central idea is simple but important. In enterprise AI agents, the cost of work is not set only by the model, it's also set by the orchestration layer around the model. The paper calls that layer the harness. So let's go to the next slide. When people try to lower AI costs, the obvious move is to compare model prices. Which model is cheaper per million tokens? But the paper argues that this misses half the story. An agent task is not one model call, it's a chain of calls. Tool outputs, context replay, retries, and decisions. The harness decides how large that chain becomes. And the paper names the problem token maxing. Teams buy more capability by spending more tokens, longer reasoning traces, more agent turns, larger tool payloads, wider retrieval, and more history replay. Per token prices may fall, but total consumption can still rise. Benchmarks show quality, cloud invoices show tokens. So imagine asking an AI agent to reconcile two contracts and draft a red line memo. That sounds like one request, but under the hood, it can unfold into a dozen or more turns. The agent reads instructions, sees tool schemas, retrieves files, reasons, calls tools, receives outputs, and replays parts of that history later. The bill is the sum of the loop. So the harness is the orchestration software around the model. It decides what goes into the context window, which tools are visible, when retrieval happens, when to delegate to subagents, and when to pause, when to retry, and when to stop, etc. So if the model is the engine, the harness is the operating system for the work. The re- By the way, the interesting part of the paper is the controlled swap. The authors held the work constant. 22 logged enterprise tasks, the same prompts, the same six models, the same judge protocol, and the same price table. Then they changed only the orchestration layer, a conventional baseline agent loop versus the writer agent harness. Okay, next. Then then you can say the headline result is striking. Across the six models and 22 tasks, cost per task fell from 21 cents to 12 cents, a 41% reduction, and median wall clock time fell from 48 seconds to 27 seconds, a 44% reduction, and tokens per task fell from 14.2 thousand to 8.8 thousand, a 38%. So that's the 38% reduction. Quality moved from 0.78 to 0.81, which is the paper reports as parity at this sample size. So one of the cheapest mechanisms is the two-zone prompt. Stable material like tool schemas, system instructions, checkpoint summaries, and durable transcript is shipped so it can be cached and reused. And volatile material like the clock, file listings, latest plan state, and one-shot reminders is kept in a separate tail. The point is, physical prompt design make the stable part stable and don't position it with pattern changes. And then the paper lists several practical mechanism families. Catch shape discipline makes provider catching effective. Structured compaction prevents full history replay. And context offload keeps bulky work in files. Subagents or references. Zero token waiting means the system pauses durably instead of polling. Failure span governance prevents retries and broken loops from multiplying the bill. And the model agnostic floor lets the same orchestration layer benefit multiple models. Okay, next, you can say this is where the result becomes more interesting than a model comparison. Every evaluated model got cheaper under the harness. The reported cost reductions range from about 33% to 61%. The paper argues that this is a signature of a layer level effect. If the gain came from one model's behavior, the effect would be uneven. Instead, the orchestration layer moved the bill down for all of them. Okay, next, let's say the quality story is more nuanced. The paper suggests that stronger models extract more quality from the harness, while weaker models may not benefit as much from advanced orchestration features. A useful way to say it is like this: the harness sets the floor and the model sets the ceiling. The harness can make work cheaper and more controlled, but the model still determines how much capability can be converted into better output. Let's see this discussion. The paper makes its biggest business point. The harness is the price setter. The model still matters for capability, but the harness controls how much model you buy for each task. It decides how much context gets replayed, how tools are exposed, and how retries happen and how work is routed. At fleet scale, that becomes real money. Using the paper's blended numbers, 1 million agent tasks per month would save about $90,000, or you can say $1.08 million per year from orchestration alone. And the authors also argue that teams should change the KPI. Don't measure quality by itself. Put completions per million tokens next to quality because that's the number that predicts the bill. And finally, route tasks by feature demand. If a task needs sub-agents or advanced orchestration, send it to a stronger model. If it's a simpler grounded Q&A cheaper model may be enough. So, in the end, I want to say the takeaway is not that model choice stops mattering, it still matters. Token prices still matter, but for AI agents, a big controllable variable may sit above the model API, the harness. The question is no longer only which model should we use, it's also what software decides how much model we buy. Okay, I hope this video is helpful for you to think about how to save cost from your AI agents. Please subscribe and see you next time.